In this tutorial, I'll explore the intersection of large language models, LLMs, and the Julia programming language. I'll guide you through installing an LLM locally on your computer without the need for cloud services, and demonstrate how to leverage it for developing code in Julia. This approach will actually empower you to use LLMs as a tool to enhance your Julia programming workflow. Even if you don't have the required hardware for running LLMs on your computer locally, I highly recommend you to watch this video till the end, because it's going to show you how the world of programming is changing and how it affects the way we code in the near future. I'm also going to make some suggestions about the way you should work with LLMs and also how you can improve your workflow by going through some steps. Even you can fine-tune your own specific models and share them with the community. The first thing that we have to talk about is Ollama. But what is Ollama? Ollama is a platform designed to facilitate the deployment and management of large language models locally on your machine. It allows users to actually run models like Llama, Mistral, and others efficiently, providing tools for customization and interaction through a user-friendly interface. And I think that it runs on Mac OS and Linux and offers features like model quantization to optimize performance on different hardware setup. There are some key features that Ollama has and it grabs our attention. One of them is the local deployment. The other is customization, ease of use, multi-model support, and community and resources, which are really essential. If you have any questions, you can refer to them to resolve your issue. To install Ollama, you go to ollama.com, and on the main page, you see the text that says get up and running with the large language models. If you click on the download button, you see Windows, Linux, and Mac OS. I'm currently on the Windows, so I download the Windows installer. You can click on Linux and copy the command in your terminal, and for the Mac OS, you know the drill. And you can click on the models and you see a list of models. They are sorted from the most popular one, and you can just change the sort. But DeepSeek R1 is the newest model, and you see that it has almost 12 million polls at the time of recording this video. There are other models available on this page like Ollama 2, Command R7B, DeepSeek version 3. There are tons of models. I click on the DeepSeek R1. You see that it's the first generation of reasoning models with comparable performance to OpenAI O1. It has several versions like 7 billion, 8 billion, and 40 billion, and these are the number of parameters. We download the specific versions that our hardware can handle. Information about the specific benchmarks comparing the different models with different number of parameters is also provided on the same page. So now I'm going to choose the specific version that I want to download, which is the 7 billion parameters version. Copy the command Ollama run and the name of the model, and I open the Ollama, go to the command prompt, type Ollama. I get this list of commands. You see that there is serve, create, show, list, poll. I can just run the Ollama run and the name of the model, and since I have downloaded the Ollama already, I can use the Ollama list, get the name of the models that I have on my machine. For instance, over here I have DeepSeek R1 7 billion, so I type Ollama run and the name of the DeepSeek R1 7 billion. I have to type the name completely in order to run the model on my machine. Now that we have run the model, all we have to do is just type a prompt and ask a specific question and the model will respond. For example, I ask, is Julia language suitable for scientific programming? And wait for its response. The first thing you'll notice is for the DeepSeek model, we've got something in between the tags think. First, the model thinks about the prompt that you have provided and it will respond accordingly. As you may have noticed, larger models generally have more capacity to learn complex patterns and generate more accurate or nuanced outputs, but they also require more computational resources to train and run. Now, if you type /? you'll get a list of commands that you can use in this environment. But I just type /clear to clear the session, or /y to just close the session. Now that we have installed Ollama, I want to install Anything LLM, which is a versatile open source application designed to facilitate the use of large language models for various tasks. It serves as a comprehensive tool for interacting with LLMs, enabling users to use the capability of the large language models for text generation, summarization, translation, but it also provides a platform to use AI agents or create custom AI agents. The plus side of this one is you can use a user interface from the get-go, and everything is provided for you and simplified, so you can interact with large language models without any hassle. Now that we have opened up the Anything LLM, I can create a new workspace and just provide my prompts. The main page provides a general guide on how to get started with Anything LLM. Like the other one, like Ollama, this tool also has a large community that you can ask questions, create GitHub issues, and if you face anything. So I click on the new workspace and type the name of my workspace. Here I just type sample workspace, and in this page I can go to the configuration and provide the agent configuration. Here it's on the system default, but I change it to Ollama. I can use other LLM tools, but I use this one, and as you see it says provider endpoint discovered automatically, and that's it. Then I can go to vector database chat settings. In the chat settings I can also provide the Ollama for the chat interface, and then I just save the settings and I go to the page that this vector database and general settings also have some settings like you can delete the workspace and etc. But I go to the main page of the workspace and then I type my prompt. Well, now I have to provide a prompt, right? I ask, is symbolics.jl better than SymPy? So by SymPy I'm referring to Python SymPy, and it understands it, of course. So it gives me some response, and as you can see, it tries to be impartial, but not really. It's not trying to be impartial. It is biased towards the Python packages, and that's pretty obvious why, because there are tons of data out there regarding Python, but it doesn't mean that all things that the LLMs say is true, and that's such an example. So I changed my prompt to something else, like providing more context. I need maximum performance, and it provides something which makes more sense, and it says that the native Julia implementation is faster, and there are some other aspects that it addresses in its response, and I think this one is just trying to get better and better. And you know, the nature of these large language models is in a way that if you provide more context, more information, it can provide a better response which actually makes sense. You can double click on a response and you get the markdown version of the response that you can copy and paste. You can just copy, there's a copy button and everything regenerating the response. It's the same thing. It's the same thing as ChatGPT and other large language models which are cloud-based. Finally, regenerating the response tells you that symbolics.jl is better than SymPy, and that's the irony is that we have tried, it gave us several answers, but first time it was biased towards Python, then towards Julia, and this is the nature of the generative AI and large language models. They just generate text, but with more context, their response can change. As you can see, you can use the @agent and call the AI agents. It's a whole nother topic on its own, and it's actually requires its own video, but I have to mention that for the sake of completion. And I refer to this. You can go to the documentation and set up a AI agents. It's provided on the Anything LLM docs, and it gives you the steps. We have gone through some of them, and then you choose your agent skills, and they are providing more and more AI agents, and the community is getting richer and richer, and that's really cool. By the way, if you like this video, hit that like button and subscribe to the channel. The final thing before getting into coding is introducing the LLM Studio. This is another tool similar to the other ones. You can go to the lmstudio.ai and download the LLM Studio tool. It can run LLMs on your laptop entirely offline. You can chat with local documents and several other features. It's also provided for macOS, Linux, and Windows operating systems. After installing the LLM Studio, you get a nice interface just like the Anything LLM, and as you know, cloud-based large language models like ChatGPT have API endpoints. You can replicate the same thing by going to this tab and starting a server. You can also go to My Models and check out the models that you have downloaded, or search for new models in the by clicking on the search icon, and you can search for DeepSeek, and there are several versions of the DeepSeek model which are released consecutively in different days, and they have different sizes and different number of parameters, and you know that the different number of parameters shows how accurate the model might be, because it also depends on several other factors. For instance, you see that the DeepSeek Coder model has 10 gigabytes of a size, and I go to the chat bar, and at the top of the window I select the model that I've already downloaded. I can click on the plus button to add a chat, rename the chat, or remove the chat. Here I rename my chat to example chat, select the model that I've already downloaded, Q1 2.5 Coder, and load the model. After the model has been loaded, I can see some status about it at the right bottom of the screen, mainly the amount of RAM that is used by the model and the CPU usage. Since we have loaded a new model, I asked the same question that I asked the previous model using Ollama. The question was, is Julia a suitable language for scientific programming? And the iconic moment of the response from the large language model. Obviously, the answer is yes. Julia is highly suitable for scientific programming. So let's ask for a chunk of code. For example, I can ask, can you give me a sample code for plotting the sine function using GLMakie package? Then we wait for the large language model to respond, and it provides us a sample code that we are not even sure whether it's correct or not. I mean, from the look of it, it looks okay, but we have to test it. And the other thing is, as you can see, the whole response was generated locally on our machine without using any cloud-based service. And when you go to the developer tab, you can see that you can start a server by clicking on start server or using the shortcut Ctrl-R. It even gives us API endpoints just like the OpenAI ChatGPT, and an address which we can copy and paste. It's on localhost port 1234. If you want to support the channel, please like this video and hit that subscribe button. Now I want to use those models that I have installed in LLM Studio by using them in VS Code, just like GitHub Copilot, so I can smoothly develop code and interact with large language models that I've installed locally on my machine. As you see, I have installed the Continue extension, which is an extension used for interacting with several different interfaces for large language models like Ollama or LLM Studio. I go to the settings of it and select LLM Studio, and I can also choose Ollama because it's also in the list, and several other providers are also in the list that we haven't covered because we don't really need them. And after that, after I've selected LLM Studio and I put the config on auto detect and hit next, then I select the model that I've installed in LLM Studio, for example DeepSeek R1 2.5 Coder. Then all I have to do is go into my file, hit Ctrl and I, and chat with the model that I have selected. For instance, all I have to do is just provide a prompt. For example, give me an example of plotting a sine function using GLMakie package in Julia. And it gives us an example of plotting a function. All we have to do is accept the change or reject it. I accept the change and run the code. As you see, it successfully ran the code and plotted a sine function. So our prompt worked. I select all of the lines and hit Ctrl and I. So I select all lines from 1 to 14 and provide another prompt. Let's get a little bit more creative. So I say I want the background to be black and the plot line to be white. As you can see, I'm purposefully using the worst types of prompts possible to just check out how smart the model is to fill in the gaps. So the model is going through the lines and changing them. All I have to do is accept the changes. For example, it has provided some changes. Let's just accept them and run those lines which have changed. See what happens. So you see, I get my first error after modifying that line. It seems that the modification provided is not valid one. And it happens with the large language model outputs because they might be trained on some bad data, or our prompt doesn't have enough context for the model to provide a useful response. So again, I accept the changes recommended to me by the model and wait for execution of the lines of code to see whether I'm getting the right result. As you see, it throws an error saying that type access has no field background underline color. And this is pretty obvious one, but the thing is, if you want to get better results, you have to provide more context. The more context you provide, the more reasonable answer you might get from the model. So now let's remove these lines of code and type another prompt. This time I asked the model to plot a 2D surface using GLMakie. Basically what I mean is to plot a surface in a two-dimensional plane. Let's see what sort of response the model provides. So I accept the changes and run the lines of code. We have X, we have Y and Z, and we have axis. It throws an error. It doesn't matter, we just run the code and fix that line of code which throws the error saying that invalid attribute Z label for the axis type. So I remove that attribute and run that line of code again, see whether it's fixed. So as you see, it has been fixed and we've gotten a beautiful plot. Now I select all those lines provided by the model and hit Ctrl I and provide another prompt. I say, can you plot a more complex function? Well, complex, let's say what sort of thing it understands from the word complex. So it provides us by changing the function that it's going to plot. So I run the lines of code and see the result. The result is beautiful. It is actually the multiplication of sine and cosines, and it's really cool thing. It's sort of understood that what I'm saying, but what I'm saying is in the prompt is sort of vague and it's not clear what the model must do because anything can be complex. So when I say complex function, it's not clear what sort of thing I mean is a complex function. Do we have a definition for a more complex function? No. So the model provided a good answer by changing the terms in the function that it's going to plot. Now it's time to provide more and more prompts. Technique that I'm using right now is just providing a simple prompt doing only one thing. Then I ask for another thing and another thing. The list goes on and on. But in each prompt, I focus on only one task to be done. For instance, I'm asking to change the color map of the plot to something more vivid. By more vivid, I'm not referring to anything specific, so it's up to the model to decide what is vivid. And it provides me an answer passing some color map to the surface function. The next natural thing is just to accept the answers, run the lines of code, and ask for another type of color map. For example, we've got to have a list of color maps that we can pass to the color map attribute in the surface function. So I can ask for another color map. As you see, it provides us with another color map, this time plasma, and if you run the code with the plasma color map, you see that the color map has changed and the look of the graph is different from the previous one. Then again, I asked the model to change the font size of the plot, and this time I get a different response telling me how to change the font size of the plot using the generated lines of code. Here, it passes the font size to the ax object attribute. Accepting the changes and running those lines of code, we see that the font of the plot has changed and the x label and y label size has also changed. Finally, let's ask the same question we asked the previous models, but this time from the Qwen 2.5 coder. Is symbolics.jl faster than SymPy package? And let's see what it answers. Due to Julia's performance advantages over Python, symbolics.jl might offer better execution time for computational tasks. And that's the answer from the Qwen 2.5 coder model. And I ask again, which one is faster? And let's see the response. Again, the model tends to stay impartial. Now imagine if we train specific models for the Julia programming language. I mean, giving large samples of code, billions of tokens to the large language models to learn the language and perform much better than these custom models that are available. It would benefit the community beyond comprehension. If you want to support the channel, like this video and subscribe to the channel. Also, you can check out the next video which teaches you a lot about Julia programming language. And if you're a beginner, I've also got a playlist for you to learn about Julia programming language.